Okay, let's move on to the sorting station programming. So from the picture, you can see all the different angle, right? Different angle of all the toolings on the sorting station project. Uh, all the cylinders, tooling, electrical cables, and air hose to connect in there. About the valve bank, I need to talk about a little bit more. So if you look at the that's around here around the corner, right? So if you look at the valve bank, um, altogether we have six different valves, right? There are solenoid valves. The top from the screen, you can see the top three are the double solenoid valve. If you remember what you learned from the pneumatic, right? So that's the 5-2 double solenoid valve, right? And then the other half, the other three at the lower half is the single solenoid, right? With single solenoid, on the other end, on one end they have a solenoid, the other end is a spring, right? So that's used to control different type of cylinders. We'll see the implication very soon. All right. So on the wall bank itself, as you can see on here, there are two different buttons on each valve. No, not all of them. So there are two buttons on the double solenoid valve. One is green, the other one is orange. And on the single solenoid valve, you only see one button on each valve, right? So you figure that that's the manual override for the solenoid. So if you want, for some reason, without electrical signal to energize the solenoid, you can use some object to push those buttons, but it's just for temporary manual override. I don't rely on that, and when you push the button, you don't want to use sharp object. All right, so be careful with that. Normally, we don't use this manual override. On the side over here, you will see that's the indicator light. Whenever a solenoid is being energized, you will see the color. Yeah, they change color and on and off on the side on here, right? So with the valve control, with these two different type, again a little bit review from the electro pneumatic. If it's a single solenoid valve, right? So you have to for example, on this circuit, if you want to maintain the cylinder to the extended position, you have to energize Y1, right? Y1 is on this circuit is energized by the control relay K1 normally open. That's the coil, and then look at the control on here. That's typical 3-wire control, right? That's what we learned with the seal-in. The reason for that is you have to bypass this start signal, otherwise this cylinder will not stay at the extended position, right? You have to keep this Y1 energized all the time, right? So that is the single solenoid valve. But when you have the double solenoid valve, that's a little bit simple than the single solenoid, because you have Y1 and Y2. They have the I think on the Festo they use memory as the description for this type of valve. So the meaning for that is whenever for this circuit, if you energize Y2, the cylinder will retract, right? But when you remove the signal from Y2, so whenever it's de-energized, the valve will stay to that position, and then that's why the cylinder will stay retracted. When you need extend cylinder, you just need to briefly energize Y1, right? Make sure don't energize Y2 in the same time. You only energize the Y1 for a brief time, and then the valve will switch and then stay in that position, and cylinder will stay at the extend position. So that's why the control circuit is relatively simple, right? You only need to energize the output, the signal for the solenoid, then you will get the position with the cylinder you expect it, and then it will stay there. Unlike the single solenoid valve, right? You have to keep the solenoid energized in order to stay at the position, right? So whenever you de-energize it, the spring push back, then the cylinder retract, right? So that's the hardware circuit behind it, right? So then let's look at the tooling on the Station 1, right? So with Station 1, you can see here is on the slide, right? And then we have two different cylinders, and then used as a stopper, right? So you can see that's the what I call that stopper cylinders, right? So the part being loaded on here, and then in order to feed the part through, you have to they both at the extended position, right? They have to retract the top one first, so the part slide down in between here. You can see even see the mark on the slide, and then you have to extend the top one again to block if you have more than one part, right? You don't want all the part feed through, so you have to feed one by one, right? So then whenever you want to feed the part through on there, you just need to retract the lower one, and then there's only one part being feed to the next station, right? So in this way, that's what we I said here alternately, right? So that has a sequence involved in there, right? So those two sensors indicate the parts in front of that position over there, right? So if both over here sensitivity, there's a set screw around here on the back of this the sensor can adjust the sensitivity, right? Then there's an indicator light to indicate the sensor is on and off, right? If no parts on in front of either of the sensors, then you need to send a signal to the other station to tell them there's no more parts. So that's we call purge. You will see some of the things get involved with this situation. All right. So I think let me clear out. I think it's better maybe to see a brief video and to look at the tooling first. All right. So you can let's just play here. So that's the Station 1 on here, right? You can see one by one feed in there. That's a part on here, and then load on the next one, right? So I just want briefly want you to see the operation on here, right? So that's you can see there some certain type of tooling sequence involved, and also that'll be the part load at the result load on here, then it being transferred to the next station, right? So let's start to look at how do we start to program that. All right, so over here, let me see. This is the document as the guide for you to program it, right? So the first one is what we call the I/O buffer. In a moment, I will explain that, and also set up the start complete conditions. So what we need to do is that to program the drill station, right? So you want the home position as the both tooling extent, and the sequence is C minus, C plus. So that means the clamp retract and clamp extend, the drill retract and drill extend. So that's the sequence, right? So you have to design that. So I have the demo over here on this sequence. So right now the station is homed. As you can see, the clamp over here is extended. The drill is also extended. So that's why it's homed. Then once we load the part, right? So then the clamp will retract first, and then after that the clamp will extend. And after that, step 3, the drill retract, top is retract, then extend again. So you have to design your drill station exactly as this sequence, alright, in order to move ahead with the sorting station project. So you may already realize this is exactly the same sequence as we just talked about on Station 1, because the clamp could be the top stopper, right? Because right now they are both extended at the extend position. Then the top stopper retract and then extend. The lower one will retract and extend. So that's the sequence of the station 1, exactly what we want with the sorting station sequence. All right. So then, yeah. So you can see that should be your top, and then should be the bottom, the lower, right? So that's the sequence. So that's what I mean back on here. You have to design that, and then you follow this to export your routine. Then after that, you need to open the project file from your commissioning phase. So it's not part of this video, but I have the file open, so I can show you that this is the file supposed to be at the end of your commissioning phase. With commissioning, you have the hardware set up on here, all the Ethernet I/O modules, and also with the I/O configuration, you have all the alias I/O tag and also alias to create on here. So that's not part of this video, all right? And in the same time, you may already have the main program, right? So you can see here that's the end of the commissioning phase, right? So for this, you have to do something with here, right? So you don't want this part of program being run again. So that's why you don't have to delete, right? You just need to drag and drop that into the folder called unscheduled. So once you drop it, that will be blocked from running. So you don't want what you program with the commissioning. Remember, by that time we just do a temporary testing. So that's what the commissioning means, right? So we just need to briefly temporarily test the functions, right? So now we want formally program the station, right? So then after that, we create a new program called Station1. I already show you on there. I should create on the in the video that you to see the whole process, but I already, in order to make the video shorter, I created Station1 already. So then after that, what we need to do, we need to import, right? The two routines you export with the step 1.1. Now you need to import into that. All right. So again, I already made the import. So if you open this Station1 program, I already have those both routines imported on here. And then after that, in order to make the program work, we have to create more routine, right? So first one, you probably want to call as a main, and also this one, make sure this assignment signed to as main, right? So doesn't matter what's the name you gave to the routine, but it has to be assigned to main. So then you have the main routine. Notice the icon is different, right? Then you need to create two more routines. So the first one is called the R1 underscore. That's just a name. Name is just a suggestion. All right. So in the moment, I'll show you why I named this, and then create another one. So we have R1 to R3. So we need to create R4 underscore output. So actually these two routines are what we call the buffer, I/O buffer. So that's something I need to talk about a little bit. All right. So you can see let me see the next slide. Yeah. So that's the term, buffering I/O. So this is a technique related to whenever you have Ethernet I/O, and also the alias tag already created, but that's not enough. You need to go further. There's one more step. You need to buffer it. What do you mean by buffer, right? So I'll explain that. So it's not necessary at the task during the commissioning, right? Remember, by that time we only create alias. We didn't buffer it. right? So if you Google on the Allen Bradley Rockwell manual, there's a manual that talk about this part, but I can explain this part briefly. All right. So the PLC scan, I believe that's some concept you already understand, right? So with the traditional PLC scan, it's a 3-step cycle, right? So PLC controller check the input first, then execute your logic, then update the output. And right after that, we'll go to the next scan again. So normally for this type of scan, PLC, depends on the controller, can run maybe a few hundred times, no problem, 1 second. It also depends on how big is your program, right? So with the regular the lab we designed, the PLC controller can scan your program every second, maybe 500, 600 times, no problem, right? So that's pretty decent setup with the traditional one. But with the newer one, right? So with the newer PLC controller, there's a new technique they call a asynchronous PLC scan. So what they do is that they may have more than one controller to handle different tasks with your PLC operation, or maybe even with one single controller, they could create more than one process. Then they can run the different process in the parallel time. So what that does is that they use a dedicated either a controller or a process to scan your logic. So this part being taken care by separately, right? So that's very fast running. That guarantee your logic being scanned even faster. And then in the same time, they may have a different controller or different process dedicated for the I/O update. So before we have all 3 steps into one scan, they always run in the sequence, right? Input, logic, output. But in the new setup, right, they are running in parallel, right? So that means they cause some problem, because your logic may run for example, over here 500 milliseconds, right, as one cycle, but your I/O update maybe 20 milliseconds at one time, right? They call the RPI, the request. So that you don't have to. You can search on this term, right? So that basically that means like over here it shows every 20 milliseconds the I/O will be scanned once. So you can see this is faster than the logic, right? That could be different pace. So that means your I/O may be updated during the execution of your logic. So some part of your logic at the beginning maybe check the I/O sensor, maybe it's off, but right in the middle, because that's running more frequently, right? So your input will change the state even in the middle of your logic execution. So that is a big problem, right? In the middle of the execution, your I/O changes status. So then that be inconsistent for your logic, right? This type of problem once happen, it's really hard to troubleshoot because it just happens so fast, right? So the solution for that is that we use the user logic to do the traditional, similar to traditional scan, right? So even though the I/O running really fast, and then on our user program, we take a snapshot at the beginning of your program. So that's what we call the buffered input. So we take a snapshot of the input signal, then we use this picture to run the whole logic. This will guarantee the consistency on the input signal. And then at the end, we will update the output, flush out the output, the value. So we call it buffer. So in this process, we call buffer, right? So basically, it's just we use a buffer zone instead of the real time on the input-output scan. Right? In this way, we have some sort of control, right? So in order to maintain the consistency, right? So what we do with the buffer, right? So again, you can read this. So what I can show you on here is that with the input, right? With the input buffer, we copy the alias tag. Right? You can see here, those are the alias tag into the memory tag. So this is the snapshot. This is the picture I've just talked about, right? I just talked about, right? You can copy into UDT, right? So that you need to do that anyway, right? So in this way, in the logic, we will keep using those tags. We don't use those alias anymore. And then at the end, when you finish your logic will decide the output if it's on and off, right, with the memory tag. And then at the routine full output buffer, you copy whatever you have into the alias. It's just the opposite, right? Input buffer, you copy from alias to the memory. But with the output buffer, you do the opposite. You copy from the memory tag into the output tag. Right? In this way, you can do the. So this is just an example. Let's go into the real process. All right. So let me just go back here. So I already explained the buffers, and then let's see what we need to do with the sorting station. All right. So one more thing, one more step over here, right? So as you can see here, the tags, right? So we still have the clamp and the drill. So that's where we get from the drill station. So we needed to process that. All right. So this is the part I'm going to demonstrate that for you. So if you double click the program tag, that's what I mean. You see here, you have the clamp, you have a drill, you have station, you have all this stuff. All right. So what we want to do is to change the name, because we know this is the not clamp anymore, right? So what's the name I suggest? Let me go back here. Upper. So we can call upper, right? Upper and the lower, right? So the clamp will be the upper because it retract first, right? The drill will be the lower. So in this way, we can make the tag very meaningful, right? If you open it, because they are UDT tags, right? So they already automatically change those members' name in there according to the tag name, right? So now we have the very meaningful tag name now. So I believe next one will be the buffering create, right? So over here 1.4, we want to do the buffer. So wire 32 to 35 can be buffered at extend and retract property of the UDT. All right. So if you remember, that's the electrical diagram from the commissioning, right? 32, right? You can see those are the signals into the PLC input, right? So we already finished this step. We can just directly use the alias tag. So wire 32 to 35. All right. So let's go back here. If we go into the input, double click input, then remember this is the input buffer, right? So this will be the wire 32. So that's the pre-stage at extend, right? So if you understand this, we just change to the upper, right? The pre-stage will correspond to the upper. So we just need to call upper and dot the at extend. So that'll be the extend proxy. So that's a very good buffer on there, right? So you can just copy, Control C and Control V, and this one will change to wire 33, yeah, 33, and no, sorry, that's a wrong one. Wire 33, we need to find on here somehow 33. Yeah, that's the right one. So pre-stage at retract. So this one should change to upper at retract proxy, right? So remember that's sensor, right? So you can do it by yourself. I don't have to do everything that as on here. The wire 36 and 37 need to be buffered into two new Boolean tags. So I suggest you use those tag name, right? So let's do it on the 36 and 37. So over here we can Control V and wire 36. Yeah. So this one we will call the PP upper, right? So you can use that, create a new tag, do that, right? So this is the buffer for the sensor. So just in case if you need a little bit reminder on here, that'll be this sensor, right? This sensor, the one we just talked about. Sorry. So if we go back here, let me explain a little bit. This wire 32, 33, that actually I forgot to mention. You can see here 32, 33, right here. So that's actually that's the sensor on the cylinder body to indicate the cylinder at the extend and retract position. And same thing for here. There's 34 and 35, right? And then there's 36, right? So they are all here, right? So we just need to buffer them. And there's a suggestion for the for over here. So because the tooling movement can cause the part bouncing, so you may want to add 200 millisecond delay. That's better because once the retract extend, the part maybe move like a little bit of shaking movement on here, so that will cause some problem with the sensor, right? So in order to avoid that situation, you may want to add a timer, right? So for example, if you use TON, and then I'll just use a very simple tag, right? You can create a more accurate tag, T upper, or maybe you can create a so for that you can just use 200 millisecond, and the preset is 0, right? So this is a delay. So whenever this sensor is on, you need to feed that, go through that timer. Then once this timer is done, right? So you can use this timer done bit dot done. Whenever the timer is done, you can energize this output. In this way, you just use as a buffer, as a filter. Sorry. So if the because of the bouncing, the sensor on and off very quickly, that's going to be filtered out by these 200 milliseconds. Only the one is very stable will pass these 200 milliseconds with done bit and then energize this memory tag, right? So this is what you need to do with this part. And then the other thing I want you to do to think about is that's the part with the output. So the output is the single solenoid valve. So you need to use we already mentioned that 3-wire control. Use the extend output as the break stop condition, and then use the retract as the make. Yes. So all right. So that's do that on the program. All right. So over here. We just need to go to different routine. Remember that's R1, this is R4 output. So with output, eventually we want energize the alias tag, right? So that be the for example, the pre-stage retrack. Yeah, over here wire 51 pre-stage to retrack. So eventually we want to energize this, right? So we want to energize retrack, and then so because it's a single solenoid valve, we cannot directly just use one-on-one as I show you on the example. This little bit different, right? So this one we have to use the upper dot. You can see we should, because it's to retract, so extend output. So extend output is not on, and then we use the upper retract output on, right? So retract output is on, and then because it's 3-wire control, we have to seal in less trigger, right? So once we energize this, we have to use this to bypass this one in order to keep the output energized, right? So you can figure out with the other one, right? So the lower for the lower, so because I already explained for the single solenoid valve, right? So, and on the R2 station routine, add one round before cycle start, energize the station power present if either on, and remove power present condition for the cycle complete. Okay, so that's the other thing. Remember, this is not exactly the same as the drill station, so that's why we need to do some modifications on that. All right. So of course, over here, power present. Yeah, power present. So on the drill station, you can see that's the power present. But on our sorting station, right? So especially on station 1, right? So we have the upper lower, right? So then we have to define what is the station power present. So remember, we create the PP upper, right? So that's one of the conditions. If you remember with the input, right? So I created this, but I didn't create the lower, right? So let me. You need to do the similar thing on this one, right? But on here you also need, because power present will be either one of the sensor is on, right? So that's why we need to use parallel, right? So this one we need to use a PP. Remember, I just created a tag here, but I didn't really energize that. You need to buffer it, right? So we can create in order to get rid of the error, right? So this is what we need to do with that. And also, okay, what we need to do on here to make some changes on the cycle condition here, right? And remove the part present condition for the cycle complete, right? So that's the part I need to explain a little bit on here. So if you understand the sequence on here, with the drill station, it's good. With the condition on here, whenever we take the, remember with the drill station, we take the part away. Whenever we have this part being taken away, that's the end of cycle. But on the if you if you look at here, so this is our station 1, right? Cycle complete is not the part being taken away. It's actually when you finish, you should have a part on the bowl on here, right? So that's why they're different, right? So to solve that problem, we have to delete this, right? So again, because this is different from geostation. When geostation operate, you have to have the part being taken away at the end of the cycle complete. But on the sorting station, it's different. I think I explained here. Energize the part present if either on, and remove that part present, and the following send. I think somewhere else we will operate on that. All right. So let's look at 1.6. So for the handshake, right? So with the lower retrack permit. So again, if we look at here, right? So that's the part being dropped, right? So you can see here part being dropped because of the lower retract. So like right now, when you have a part loaded on here, this arm supposed to come here to pick it up, make it clear, so then you can feed the next part. But if you don't take care of this, if you feed the next part, you're gonna have a double load on here. So that's why this lower one need to have a interlock, the handshake, right? The retract permit. That's what I mean by here. So at the end of R2 station, energize it when the alias phase 1 purpose, when the alias tag is on. In condition for lower retract auto branch. So what we need to do at the end of R2 station, energize it when the alias tag is on. For phase 1 only, we will change data to the. I think there's a mistake on here. That should be off, right? It shouldn't be on, right? That's the wire 21. It's the part being. I'll show you on here. Yeah, so this is wire 21 on here. If it's on, you don't want to retract. When it's off, you won't be retract. I will remember to change that. All right, so that's go back here. So over here, we just need to add one more run. So on this, so this is only temporary purpose on there. Wire 21, part present at the bowl, and then this one will be the lower. So I made a mistake again, but I can change it. Lower dot the retract permit. On here. This one, like I said, that should be off. When it's off, you have the permit. When it is on, you don't have a permit, so you don't want to retract, right? You understand that sequence? So let's look at understand the logic interlock. Then let's look at the tooling, right? So then let's find out the tooling for the lower retract. With the lower retract, remember I mentioned this. We just need to add more bits, more condition on the auto branch on here. So for this, we need to use exam on, and this one should be lower retract output, and then we need to change that to lower retract permit. So in this way, if the bowl doesn't have the part in there, right? So if over here, when it's off, it's on, then you have the permit, and then with the over here, this will become true. You can retract. But in the opposite, once we load one part onto the bowl on here, right? You don't want load any part anymore, right? So that's why that's the handshake and interlock we just mentioned. I think this is the most difficult part on the on this phase. All right, so I can stop here. For the rest, you can just design the HMI and test that with the station. All right, so I can just stop here for this video.